Okay, before the official video starts, here are the written note steps on how to find the maximum and minimum points of a curve. So here we go, real quick. First step, we're going to differentiate the original function. So whatever the original function is, let's say it's f of x, we differentiate it to f dash x, and hopefully by now we know how to do that. Second step is to set the derived function equal to 0. It's equal to 0 because that's what the gradient is at a minimum or a maximum. And remember, that's the original function. That's the derived function. So whatever we get there, we set it equal to 0. Next step is to solve for x. We have this set to 0, and we solve for x. We may get one solution. We may get two x's. We may even get three x's. Okay, and that's our x coordinate of our maximum or minimum. Next. Then we substitute these x value or values into the original function, f of x, to find their y coordinates. All right, so that's half of it. Plug it in to find the y coordinates. Next. And finally, so you've got a coordinate or maybe a couple of coordinates, and you don't know if they're a maximum or minimum or neither. They can be a stationary point. So determine if that point is a max, min, or neither of those. Choose values on both sides of this x value to find their gradient. Okay, and how that looks is like this. If the gradient on both sides of the x value look like that, it's a minimum. If the gradients on both sides of the x value look like this, it's a maximum. And if it looks something like this, then it's neither a maximum or a minimum, it's a stationary point. And I go over these examples more with tables in the examples following this lesson. All right, so for finding maximum and minimum points, one thing we need to remember is that we're given a curve, and the curve does not have a constant gradient anywhere along that curve whatsoever. But the one thing we do know is that at the turning points, these are the turning points, is that's when the gradient is 0. Okay, so the turning points, and I wrote that down right here, that's when I know the gradient of that tangent line at the turning point is always 0 or flat. So I wrote it because here are the different ways we can write it. Dy by dx is 0. You know, f dash x equals 0 if the function's written as h of x and h dash x equals 0. But the key point here is if you're finding maximum or minimum is you differentiate it, set it equal to 0, and solve for x. Okay? So let's look at this example right here. All right, so what we're going to do here is to find the coordinates of the turning point, we have our original equation. We're going to differentiate it to find the gradient function. The gradient function is the dy of dx or f dash x or whatever you have, and set it equal to 0. So let's try that first. So I've got y dash, pretty easy one to differentiate. 2 goes in front of the variable, take 1 off the exponent. 2x minus 6 is my gradient function. Okay, I didn't say in the problem, find the coordinates of the turning point for this function, and I want you to figure out if it's a minimum or a maximum. Okay, so we differentiate it, and a local minimum or maximum is when the gradient is equal to 0. So we set this equal to 0 and solve for x. This is a pretty easy one to solve for x. Negative 6 to the other side, making it positive. Divide by 2, and I get 3 equals x. That's my x coordinate of the turning point. And to find the y coordinate of the turning point, I simply take the x value and substitute it into the original equation to find the y. That's what I get when I substitute it into the original equation. Work it out on the calculator or in your head, and I should get 6 for the y coordinate. So that means my coordinate for the turning point is 3, 6. Okay, correction on that one. Should have done that one in the calculator first and not in my head. The y coordinate of that is negative 3, not 6. So my coordinate here is 3, negative 3. But if I want to show that, what is that, a local maximum or minimum? I know that from my shape, that's a parabola. That's going to be some shape like this. So I know that it will be a minimum. I know that that will be 3, negative 3. But I'll show you a way to figure that out if you don't know the shape of the graph. Okay? And what you do in order to figure that out is you find the gradient on either side of the x-coordinate. So let's put that down on paper. Okay? So to find if this point's a maximum or minimum, we're going to look for the gradient on both sides of x equals 3. When I say both sides, I mean less than 3 and more than 3. And that'll tell us if it's a local maximum or minimum. And I'll show you a table to set up for any curve, whether it's a parabola or not. Okay, so here's the table I set up if we want to prove that it's a minimum or maximum. My x value of the turning point was 3. And I want to pick a value to the left of that. To the left of that means that it's going to be less than 3. And to the right of that, which means it's going to be more than 3. Okay? And so the test means what number am I going to put in there? Obviously, we want to put a number that's easy, not like 2.3, just 2. That's less than 3. For equaling 3, that's just 3. For more than 3, we'll do 4. And now what I do is, since the gradient function tells me what the gradient is at that point, I take this value and substitute it into my gradient function. Okay, my gradient function was right here, 2x minus 6. So when I substitute 2 in, I get a negative 2. 2 times 2 is 4, minus 6 is negative 2. When I substitute 3 in, well, I better get 0. I do get 0. 2 times 3 is 6, minus 6 is 0. And when I plug in 4, I get a positive 2. Okay? And right here, what you should draw is just a picture. A negative gradient looks like that. A 0 gradient looks like that. And a positive gradient looks like that. And when you have something that looks like this, where it's a positive gradient to the right of it, and a negative gradient to the left, that means you've got a minimum. Okay? Therefore, this point that I messed up on there, sorry about that, 3, negative 3 is a minimum. And even though, yes, we can find this out on a graphics calculator, we can find it out on a graphing app by just touching the screen twice, this does give us a good idea of understanding what the gradient function tells us. If I have something like this, then I've got a local minimum. And if, in a different example, if I have something that looks like this, where I've got a positive gradient and 0 and a negative gradient, well, then I've got a maximum. Okay? And if I have something other than these two, and that looks like a maximum, kind of, you know, and that looks like a minimum. And if I've got something that's a positive gradient, 0 gradient, and then another positive gradient, well, I have neither. I don't have a minimum or a maximum. That's not a turning point. It's a stationary point, though. Okay? So, I think I spelled stationary right there. Okay, so these are the things, right? These guys right here are what we want to look for when we make this table up. So, in this example, we know that graphs to a cubic, like I've said. That's going to graph to positive cubic, up, down, up. And I'm going to have a maximum here and a minimum here. And like I said, the smaller x-coordinate will be the maximum, and the bigger x-coordinate will be the minimum. But we need to show it. So let's differentiate this equation first. Y dash equals, bring the exponent in front and multiply it to the coefficient. 3 times a third is just 1. So that just, I don't need to put a 1 coefficient there. And take 1 off of the exponent. So that differentiates to x cubed. This differentiates to 2x. And that differentiates to minus 3. Now set it equal to 0 because that's what the gradient of the tangent is at those points. and solve for x. Now obviously here we're going to get two solutions for x. One because it's quadratic, and two because we have a max and a min on our curve. Now at this point you can solve this on the graphics calculator quite quickly, but this does factorize to x plus 3, x minus 1. Let me just check that. 3 times negative 1 is negative 3. 3 plus negative 1 is 2. Okay, so solve for x. So my x coordinates are x equals negative 3 or x equals positive 1. Okay, so hold on to those for now. Okay, so just looking at this real quick, the negative 3 value is going to be the maximum because that's smaller, and the positive 1 value is going to be the minimum because that's the bigger of the two. So what do I want to do first? Why don't I just find the actual coordinates of that? So to find the coordinates of this one, I'm going to take negative 3 and substitute it back into the original equation. Okay, I'll substitute x equals negative 3 into the original equation first and see what I get for y. Okay, I got a y coordinate for 13. So that means one turning point is that one right there. And I'll substitute for x equals 1 into my equation here and see what the y coordinate is for that one. I get 2 1/3, or if you were 2.3 recurring or whatever, if you want to decimalize that, you can. So my other turning point, which would be the minimum, is plug in 1, and out comes 2 1/3. Okay, so those are my two turning points. Okay, and finally, to find the nature of the turning points, I'm going to do that same thing I did in the previous problem where I find the gradient on either side of these x coordinates here. So that means if x equals negative 3, I'm going to want to pick one bigger than negative 3 and smaller than negative 3. For x equals 1, I'll pick one bigger than 1 and smaller than 1 and see what my gradients are doing. Now, they better be a max and a min because I know that from the basic shape. So the test, this guy is going to be negative 3, greater than negative 3. What's greater than negative 3? How about negative 2? What's smaller than negative 3? That's negative 4. Okay, so let's just do this one first. So we're going to take all three of these values one at a time, substitute them into the gradient function to see what my gradient is doing. This one better be 0. I know that. Okay, so substitute negative 4 in there, see what you get. Substitute negative 2 into the gradient function and see what you get. So I get a positive gradient, which looks like that, a 0 gradient, which looks like that, and a negative gradient. Therefore, that's a maximum. And we do the same thing here to prove that it's a minimum. I chose 0, 1, and 2 for that. Sorry about that mess up there. This will give me 0. Substitute 0 into the gradient function there. And substituting 2 into the gradient function, you get. Okay, that's a lot of work. So I've got our maximum point there. Negative, 0, positive. Therefore, that's a minimum point. And this is how we can find any max or min for any curve. It's just by picking a point either side to find the gradient of the given x coordinate that we've figured out from solving for x from the gradient function. Okay, well, good luck with that. See you guys.
Thank you.
Bye-bye.